So now that we've showed you a few straightforward alternating series tests, I want to show you this alternating series and might throw you a little bit of a curveball here, so watch out with this one. It says it's alternating, it's n over the natural log of n, so the very first thing that we test for is decreasing, and so is this decreasing? Well, first thing I say is, well, I know the natural log of n plus 1, natural log of n plus 1 is greater than the natural log of n. So my next term, is it bigger than my previous term? Well, it looks like it until I introduce this numerator. Notice it's the next term, so that's got to be n plus 1. And this, wait a second, can I say that n plus 1 is less than n in the numerator? I can't guarantee those. And so this is not going to be an inequality that's helpful. Instead, I'm going to have to go back to the derivative. So a lot of alternating series, I can check just using that inequality for decreasing. But notice this one I'm going to need to use the derivative. So here's the derivative. Low d high minus high d low, the low squared. There you see it. It's when is this equal to 0, my critical point. So I get the natural log of x is equal to 1. Exponentiate both sides. The critical point is that x equals e. And so if this is the derivative, notice less than e, this thing is negative. Greater than e, well, that thing is positive. And so something is going on here. I can't use alternating series test because this is increasing. So I'm going to have to switch tests. Instead, what am I going to do? I'm going to do the nth term test. But remember, the nth term test does look very similar to the second half of the alternating series test. But I'm not going to be concerned about this negative 1 to the n. I can look at this without it. I really just need to find out, is this thing headed to 0 or not? And so as I look, I take that limit. I'm going to use L'Hopital here, since this is infinity over infinity. Use L'Hopital. Notice that's 1 over n. And so now if that goes to infinity, I've got 1 divided by 1 over n is the same as multiplying by its reciprocal, n over 1. And so 1 times n is just n. As n goes to infinity, it is infinity. Now, if you want to argue that it's the nth term test, you're actually using that negative 1 to the n, you could say plus or minus infinity, but regardless, it is not equal to 0. And so this thing does diverge by the nth term test, not by the alternating series test. So alternating series proves convergence. Nth term test proves divergence.